All right, we're going to divide polynomials and use that division to factor a given polynomial. This is a fourth degree polynomial, which is rather large that we need to factor. So what I want to do is first try to see if there's a greatest common factor, which in this case there is not one. So what we're going to have to do is start finding rational roots of this equation. The easiest way to find it is to look at a graph of this, 3x to the fourth plus 4x to the third. Then minus 18x squared minus 4x plus 15, and we just hit graph. Now we can look at the places where this is going to cross the x-axis, and it crosses at a couple places that we can tell, and one of those places is at -1, another place is at +1, and then we have some sort of fraction answer that I don't really know about right there. So what I'm going to do is I'm going to pick one of those. So I'll pick -1. So we're going to say x is equal to -1. Now this is a root of the equation that we have here, which means that a factor of the equation that corresponds to that is x plus 1, because this, if I set equal to 0, would get me -1 as an answer. Now that's going to leave me with something, because what I'm going to do is divide the original equation by the x plus 1. I'm going to take it out, and I'm going to use synthetic division to do that. So I'm going to put -1 in a box, because that's what the number is that I need to be dividing with. 3, 4, -18, -4, and 15 go on the outside. Do the synthetic division process. 3, -3, 1, -1, -19, +19, and that would be, what, -15 or +15, -15, and 0. Now this number should always be 0. If it's not 0, that means we screwed up somewhere. Now this will get me the stuff that's left over in the parentheses. 3x now to the third plus 1x squared minus 19x plus 15. Now this might still be factorable, so what I'm going to do is I'm going to look back over at my graph and see any other rational roots that go into it. And we can clearly see over here that it does have a rational root at +1, which means not only does x is equal to 1, but x is equal to 1 and -1. Which means I could not only just pull out an x plus 1, which I've already done, but I could also pull out an x minus 1, because x minus 1 will get me a x equals +1 as my answer. But that's going to leave me something else left over, and I don't know what that is. So I'm going to have to do synthetic division again. This time it's a +1 in the box. The numbers are going to be the stuff that's left over already, which is going to be 3, 1, -19, and 15. Going to bring those down and get 3. 1 times 3 is 3, 1, 3 make 4, 1 times 4 is 4, -19 and 4 make -15, -15 and 1 make -15, and that cancels out to get 0. So now that leftover stuff is going to be now 3x squared plus 4x minus 15. And that's good. What we can do there, since that is a quadratic equation, is I might be able to factor that. I don't know if I can or not, really. I'm going to just have to try it and see what happens. So we're going to use the quadratic equation techniques. We already have an x plus 1. We already have an x minus 1. What we need to do is factor this. 3 times 15 is -45. All right, -45. It's not that hard to make numbers. We say 9 and 5. 9 times 5 is 45. One of them has to be negative. In this case, it should be the 5 that's negative, because we're trying to make a +4. So we're going to write that as a grouping problem. That is 3x squared plus 9x minus 5x minus 15. And we're going to group that stuff. So when I go through the grouping process, I'm going to go ahead and say 3x can come out, which will leave me with an x plus 3. -5 can come out, which will leave me with an x plus 3. And then that means this is going to factor into 3x minus 5 and x plus 3. Don't forget, we still have these factors out in front, x plus 1 and x minus 1. Now these are all linear factors, nothing else is factorable, so I can stop here, and that is the fully factored version of this problem. We have another example just for kicks and giggles. What we want to do is look for it and see if it's got a GCF, which it doesn't. So we're just going to have to graph it. 7x to the fourth minus 19x to the third plus 15x squared and minus x minus 2. Now what I'm going to look for is places where this is going to cross the x-axis, and as it gets graphed we can see that it crosses near 1, and it actually crosses through 1 and near 0. So what I'm going to do is just look at the +1. We can see clearly that it's going to be x equals 1. That means x minus 1 is a factor. Okay, so it's going to leave me some stuff left over. I don't know what it is. We're going to have to find that stuff right now. We put a positive 1 in the box. 7, negative 19, 15, negative 1, and negative 2 come out. I love it when it's 1 because it makes the numbers really easy. 7 comes down. 1 times 7 is 7, negative 12. 1 times negative 12, which is 3. 1 times 3 is 3, which is 2. 1 times 2 is 2, which is 0. So the stuff that is left in the blank would be 7x to the third minus 12x squared plus 3x plus 2. Now I hope that's factorable by grouping, but it's not in this case. If you look at the first two things, it's not going to be factorable by grouping. So what we're going to have to do is something similar. We're going to go back to the equation. We're going to type in the new equation, which is 7x to the third minus 12x squared plus 3x plus 2. And then I'm going to hit graph, and we're going to look to see where this crosses the x-axis. Now you can see clearly that it's again going to touch the x-axis at 1, which means I'm not going to just have an x minus 1, but I'm going to have an x minus 1 squared. I'm going to have 2 of them because, again, we have 1 as a solution to this. So we have to figure out what's left over whenever I divide it by another x minus 1. So again, I'm going to put a 1 in the box. This time it's going to be 7, negative 12, 3, and 2 that are on the outside. Again, we're going to bring down the 7, put it up there, negative 5, negative 5. Combine those as negative 2, 0. So that'd be 7x squared minus 5x minus 2, and that's what's left over in the blank. Now I hope that's factorable, or maybe not if we want to stop doing work, but let's just hope it is. 7 times negative 2 is negative 14. Numbers that multiply to a negative 14 that add to a negative 5 are going to be 7 and 2, but this time it's going to be the 7 that's negative. So we're going to write it as a grouping problem. 7x squared minus 7x plus 2x minus 2. Group those guys together. 7 comes out, or 7x comes out, which will leave me with an x minus 1. 2 comes out, which will leave me with an x minus 1. Or fully factored, that's going to be a 7x minus 2 times x minus 1. Don't forget, we still had these x minus 1 squareds on the outside, so what I need to do is say, well, how many x minus 1s do I have? I have 1, 2 up here, and 1 more down here, which would really mean it's 7x minus 2 times x minus 1 cubed. And that is the fully factored version of this equation.